Given these two functions f and g, we're asked to find f plus g, f minus g, f times g, and f over g of x, and all their respective domains. The two functions we're starting with, f of x is 2 plus 1 over x, and g of x is 1 plus 1 over x. And so we'll start by just finding the functions we've been asked to find. F plus g of x, well, that's the function f, plus the function g. Nicely enough, we can combine some things here, right? 1 and 2 make 3. 1 over x plus 1 over x is 2 over x, and there's a function f plus g. Next up, f minus g of x. I think in the examples we're doing here, this might be my favorite of them, because I can definitely do some simplification here, remembering to distribute that minus through my parentheses. 2 minus 1 gives me 1. 1 over x minus 1 over x. Hey, this function is always equal to 1. For the x values that are in the domain, we get out a 1. And there's the rub. The x's have to be in the domain. We're going to talk about the domains of these functions here in just a minute. But for right now, let's go on and find f times g of x. So that gives me 2 plus 1 over x times 1 plus 1 over x. And we're going to multiply these together by distributing. 2 times 1 gives me 2. 2 times 1 over x gives me 2 over x plus 1 over x. And then finally plus 1 over x squared. Those middle two are like terms, so I can write this one down as 2 plus 3 over x plus 1 over x squared. And there's f times g. Just one more function to write down, f over g. So this one gives me a compound fraction at first. I never want to leave an answer as a compound fraction, as an expression that has little fractions in both the top and bottom. So I need to simplify this. And what I think I will do first is use a little trick where I multiply the top and bottom of my big fraction by the least common denominator of all of my little fractions, which here is just an x. I distribute on the top and bottom, and now I've simplified my function. I get 2x plus 1 all over x plus 1. And there's my nice happy function. But I thought I'd show you another way of simplifying that compound fraction. I like that way. I find it nice and straightforward, but here's another method you could use, where instead of multiplying top and bottom by the least common denominator, I just find a common denominator on the top and bottom. So instead of just 2, I multiply top and bottom by that x. I get 2 over x plus x. Here I get x over x plus 1 over x. And now what I can do is on top and bottom, rewrite those as one fraction. So on the top, I have 2x plus 1 all over x. And on the bottom, I have x plus 1 all over x. All right, well, now I can do a little bit of work by remembering that division is the same as multiplying by a reciprocal. So I leave the top alone. The division becomes multiplication, and I flip the bottom one, finding its reciprocal. The x's cancel, leaving me with 2x plus 1 all over x plus 1, that same expression I got before. So there we have it. We simplified that 2 different ways. I like that way, but you can do whatever works for you. I only really need that written down once. So I'm going to erase this a little bit so I can find some domains. And what I remember about finding domains of these functions put together through addition, subtraction, multiplication, and division is that these 3 have the same domain. And I find that domain by finding the intersection, the overlap of f's domain and g's domain. So if I look at my original functions, well, if I just look at the function f of x, the only x value I'm worried about is 0, because I'm not allowed to divide by 0. If I look at G, I have the same problem. So the domain of F and the domain of G are the same domain, which means they overlap everywhere, telling me the domain of these three functions, the domains of F plus G, F minus G, and F times G must be that domain where they overlap everywhere, from minus infinity to 0, union 0 to infinity. The domain of F over G is the same domain, except I have to remove any values where g of x is equal to 0, because it's on the bottom of my fraction. I'm not allowed to divide by 0. Now, I could cheat and look ahead here and realize what x I'm going to have to throw out. But I want to go through the work I normally would. So I'm going to set this function, g of x, equal to 0. It's always nice to solve an equation anyway. So I could take 1 away from both sides. I get minus 1 equals 1 over x. Multiply both sides by x, and I get minus x is equal to 1. And then finally, x is equal to minus 1. That would make the bottom of this fraction equal to 0. So I have to throw out minus 1. So I have a domain from minus infinity to minus 1, from minus infinity to 0, union from 0 to infinity, throwing out that one value at minus 1 that makes the bottom of my new function equal to 0, whether I'm looking here or looking here. And there we have it. We have found the domains of these four functions. Now, the domain of f minus g is this. I'm not allowed to plug in 0. If I try to plug in 0, it's still undefined. But for anything else in that domain, you plug in an x and you get out the number 1. And that's at least a little bit cool.